Here we're going to be learning something about astronomy, about the world that we live in and the world around us, and much, much further than where we live. So we're going to start off here with the sun. Now, I went ahead and labeled it on the board here. This is the sun. These little marks here are planets, individual planets. As you'll see here, we have 4 marks here. Then we have 4 more marks from here to here. And then there's another mark right there with a P. Can you guess what that P will stand for? You're right, Pluto. That is the furthest planet that we used to know about. But now there's more, called dwarf planets. And Pluto is not considered a large body planet. The main reason is because Pluto and the surrounding neighborhood of that dwarf planet is not cleared of debris and doesn't have any satellites or objects that are circling or orbiting Pluto. Pluto's just out in the middle of a bunch of icy objects. Like this right here. Just a bunch of comet-like icy objects floating in the Kuiper Belt, which Pluto is on the very edge of the Kuiper Belt. We'll get to the Kuiper Belt in a minute. I want to reverse back a little bit here towards the sun. So, this distance here from the sun to right here, this third notch, that is 1 astronomical unit. 1 astronomical unit is the distance from the sun to the earth. 1 AU is from here to here. So I'm going to go ahead and list the AUs of all the planets. The inner body planets here, that is divided by asteroid belt here, are Mercury, Venus, Earth, and Mars. Mercury is at 0.387 AU. Venus is at 0.723 AU. Earth at 1. And Mars at 1.524. Now, past Mars and the asteroid belt is going to be the next planet, Jupiter, which is at 5.2 AU. And then we have Saturn, which is at 9.5 AU. Uranus, which is at 19 AU. That is crazy to even think about. 19 AU away from the sun? You gotta just think how fast light travels from the sun. Which technically, light is going to travel just underneath 300 kilometers per second. It's like 299,000 and some change. But you can pretty much just round that to 300,000 kilometers per second. So, moving at 300,000 kilometers per second from here to Earth is 8 minutes. That's 1 astronomical unit. Now, times that by 19 to get all the way out here. So, Uranus is at 19, and Neptune is at 30. Now, also, Neptune is at 30 AU. And starting at 30 AU is going to be the Kuiper Belt, like I was saying before. The Kuiper Belt is between 30 and 55 AU. The Kuiper Belt is a donut-shaped region of icy comet-like materials, or bodies. Could be asteroids, could be remnants of planets that were blown up millions of years ago. But that's what is between 30 and 55 AU. And then we have Pluto out here, which is just under 60 AU. At 59.2 AU is Pluto, the dwarf planet. There is one more dwarf planet that is past Pluto, and that is Eris. Eris and Pluto are actually roughly the same size. Pluto is slightly a bit larger than Eris. But Eris here at 67.95 AU. Now, what's really interesting is that right after this, well, maybe here, is 80 AU. And from 80 AU to 200, which is probably over here somewhere, because I can only really mark 120 right there. But between 80 and 200 AU is something known as the termination shock. The reason it's known as the termination shock is because of the sun's outgoing radiation. At this point, the sun's solar radiation, the energy it's putting out, is getting hit by an interstellar medium. or you can just pretty much call it space. Free space. Space that's past all this other stuff, all these icy body comets, all this other radiation and spheres. So this is technically the heliosphere. The heliosphere is everything encompassing around the sun. The heliosphere is considered to be all the sun's energy. All the light and energy that is thrown off by the sun is in the heliosphere. That heliosphere stops at 200, which is also the point of the termination shock. So the termination shock is at 200, and right after that, it's going to be the heliopause. The heliopause is very hot. It's where all the sun's radiation has been throwing out in all directions for a long time, and it has finally met its max. It can't be pushed out anymore. It stopped. And that's where that galactic medium is at. The density between the plasma of the heliopause and the density of space past it. Now, what's really going to blow your mind is that the heliopause is about 200 AU from the sun, which we've already looked at here. 1 AU is here. 200 is way down there. I mean, it takes thousands and thousands of years for us to travel from here to there, even in a spaceship going 37,000 kilometers per second, which is roughly the speed of Voyager 1, which has just recently passed through the heliopause. But from 200 AU to 100,000 AU is the point of the gravitational pull of the sun. The sun's gravitational pull can actually pull bodies, other planets, comets, asteroids, anything out in space for 100,000 astronomical units, which is roughly 2 light years. 2 light years traveling, 2 years traveling at 300,000 kilometers per second will get you to the edge of our solar system, where this gravitational pull of the sun meets the end. So past that, 100,000 AU is nothing. It's the next solar system over. So, that is just putting things in perspective for you of how big we are compared to the rest of our solar system. And what's past that. And it's a lot of questions and a lot of open space for us to think about. Till next time, I'm Mr. Evans.